So this is a quick, really quick introduction video to optimization word problems, which is the next step. So you just got done using the first derivative test to find where the graph is increasing or decreasing, and then from that being able to tell where the extrema are, meaning the high points or low points or the maximums or minimums. So now we're going to use that skill to solve some problems. So you're going to be given some word problems where it is looking for a maximum value or a minimum value. So the first step, so I've written out some steps, and you can really follow these 5 steps every time you do an optimization problem. So the first step is to actually identify that it's an optimization problem, because if it's not an optimization problem, then you don't want to use these 5 steps, because these are specifically for optimization problems. So usually in a optimization problem, there's going to be a word that gives it away, and that's what step 1 says, identify the word in quotes. And there's going to be some word that means to make as big as possible or to make as small as possible. So if you say you're looking for the well, if it says you're looking for the maximum or anything, that's a dead giveaway. But it could be, say, looking for the longest or the greatest length or the greatest distance or the highest profit or the lowest cost or the any word that means the maximum of something or the minimum of something. And so the first, when you're reading and this is one thing about word problems, a lot of people have this hang up about word problems. Because generally what people do when they do a word problem is they just read the whole thing, trying to make some sense of it. And it's much better to go to a word problem looking for something rather than just reading for general information. And so generally when I do a word problem in calculus, I often read the problem several times, looking for something different each time. So the first reading of the problem, you're just looking for the word. And usually it comes towards the end of the word problem. Not always, but usually. So you're just reading, not really registering what it's saying, until just looking for that word that indicates this is a optimization problem. Okay, and once you find it, then you want to pay close attention to what that word applies to. Because step 2 is to write an equation for the thing you're trying to optimize. So if you're reading you come to the word that says find the greatest distance. Well, then that means you need to write an equation for some distance. Or if it says find the nearest point, again, then you need to write an equation for a distance, because that's talking about the distance being small, right? If they say you need to find the value that gives you the greatest profit, that means you need to write an equation for the profit equation. So step 2 is to write some equation, and you can't just write any equation. You need to write an equation that represents the thing you're trying to optimize. So these step 2 and 1 are very tightly tied together, because once you find the word, then you should look really close to what is the word applied to. Is it applied to a distance, a profit, area, a volume? You want to pick, and then write an equation for whatever that thing is. Step 3 is to make some adjustments to the equation if necessary. So for example, if you write an equation and there's too many variables in it, then you're going to have to go back to the word problem and find some way to eliminate one of the variables. Because when you're in the problems that we just did, where you're finding the max and min using the first derivative test, you really can only handle 2 variables, a dependent variable and an independent variable. So you got to make that adjustment sometimes. Sometimes you don't have to. You just have an equation with 2 variables in it. Okay, and then step 4 is take the derivative to find the extrema. So that's step 4 is basically what we've been doing so far, where you take the derivative, set it equal to 0, check for undefined points, and you find those critical points, and then one of those critical points is going to be your answer, or it's going to lead you to your answer. And then of course that step 5, basically you answer the question. So step 4 is going to give you some critical points, and then you got to figure out. So if they ask you for when are the 2 points nearest, then in this case, when you find the critical points, one of those is going to be your answer. But if they say, what is the smallest distance, then you're going to find some critical points, and then one of those you're going to plug into the original equation to get your answer. So step 5, you really have to go back and read the question again and find out what is it actually asking, and then take the information you got from step 4 and apply it to get the answer. Okay, so that's a real general overview of what optimization problems are. The key is this beginning here, identifying the word. At first, it'll be easy to know these are optimization because the first worksheets you're getting are all optimization problems. But eventually, you're going to get some where the word problems are mixed in together. So then one will become even more important because you'll have to. If you don't find the word, then you will assume it's not an optimization problem and you want to go do a different method. But even if you already know it's an optimization problem, this step 1 is still really important because you have to find the word to know what it's applied to so you know what equation you need to write. Okay, hopefully will set you off on the right foot. There's a bunch of other videos of me working through examples, and so pay close attention when I work through examples. I won't necessarily highlight step 1, step 2, step 3, but you'll hear me using some of this vocabulary.